So I have my IntelliJ open now in presentation mode. Let's start solving this problem here. I will take the same name of the method as given in lead code. Okay, and I will mark this as final. So let's start with our base case. So we started with our base case as level is equal to 0 and the left pointer and right pointer as 0, which covered our this first, and then we have to calculate the farthest based on this formula that we already deduced in our previous video. Level is equal to 0 and just mark it as left, right. Okay. Now we have to see our base condition was that when the right has reached the last index, right, based on the formula here. So this is when I have to like iterate. So if while right is less than nums.length minus 1, right? Better let me put it in brackets. And okay. So this is the loop that we are creating, and we'll keep on calculating the farthest point, right? The farthest we can jump. We start with 0 first. Okay, and the farthest is that it's I plus nums of I, right? So, but before that, we have to also loop between left and right. So it would be I is equal to left and I is less than equal to right. As we mentioned that for this next case, like 1 and 2, so from 0th level, we found that we can reach farthest is 2. So it means that the next level would be at least starting from 1 to 2, 3 and 1. Now we have to iterate through the next level, right, from starting from left pointer 1 to right pointer 2, and we have to see that what is the farthest we can jump from this level to the next level. And again, using the same formula, I plus nums I, and we have to see the maximum out of it. So here we already calculated that 1 plus 3 equal to 4 is the farthest we can jump from this level to the next level to the index of 4. So here we will do the same. We calculate the farthest for the whole left to right. What is the maximum we can get? Would be max of farthest and I plus nums of I. Again, same, we are doing the same iteration. We are trying to get the maximum from 3 and 1 from these two indices. So we get the farthest now using this for loop, and then we update our left to be right plus 1 for the next level, and right would be farthest. So we update it the same way as we are doing here. We move right, left is equal to right plus 1, and right is the farthest we have calculated from the previous level. And then we are covered with one level, and then we have to increment our level. This is all the formula that the algorithm that we just deduced in our previous video. And then we have to simply return the level, because once we reach right as 4, which is this one, in this case, we have to simply return the level. So this is all about the algorithm and in the Java. And let's try our examples here. Let me take the same example again from lead code. So I will take 23114, put it here. So I've taken both the cases, 23114 and 23014, and we expect the output as 2. Let's run this now. Okay, so we got the answer as correct, 2 and 2. So let's copy this code and submit it in lead code. Get some space here, and I'll submit it. Okay, so it was all good, and we can see it's quite efficient as well. So let's quickly do the time and space complexity analysis. So for the time complexity, we can see that we are only using one loop here, one while loop here, which iterates to each of the numbers. So that's why it would be O of n. And for the space complexity, we can see that we are not maintaining any extra space. We are not creating any 1D array or 2D array to store our results. We are just doing it inline. We are just updating this left and right pointers as we iterate through this loop, right? So again, it would be O of 1. So it means that space is, that's why our answer came to be very efficient, performance efficient in lead code. So guys, this was all about the jump game 2 problem. So we have solved 24 problems so far, and the 25th problem would be the house robber 2, which would be our next problem. So we will cover in this tutorial series on dynamic programming. Just to iterate that this house robber 2, this is the second problem, and the house robber 1, the original house robber problem, we solved this problem before, which was our 10th problem in this series. So I strongly suggest that before we proceed with house robber 2, just again look for my video where the 10th video problem that we have solved together, the house robber problem first, because based on the knowledge that we have solved using house robber, our 25th problem on house robber 2 would be done. So see you all in the next video.